you're home. Okay, if you're watching this video and it's not like March 2020, then you don't know what the heck I'm talking about. Or maybe you look back, but today is day one of coronavirus stay home. So hopefully you guys are staying healthy. Hopefully you got toilet paper, because apparently the world went crazy. I went actually grocery shopping this morning to look for toilet paper. There was none. So you know I am completely full of knowledge for you today. Oh my God. The comedy hour is about to start. Believe it or not, when we moved, we lost all of our Dunkin' Donuts mugs. I have no idea where they are. Trust me when I tell you, oh my God, they're on that shelf over there. I just found them. Maybe I'll show them and I'll bring it back in the next one to prove that I found them. But trust me when this, I tell you, this is Dunkin' Donuts coffee. All right, kids, this is what we're going to do. This is Algebra 2 review for the whatever, how do I get rid of that dumb thing? For the Unit 7 trigonometry test, okay? So after you watch this and you go through this stuff, I'm telling you that test is going to be easy. So for a little bit, I'm going to be Mr. Key. Now, if you haven't tried these problems, you probably should. I need to get my calculator up, though. So I don't know where that is. There's TurboTax. That's useless. Well, I think my computer's. Oops, that's not what you want. That's not what I want. I think my. Oh yeah, whatever. Cancel. Are you sure when it click? Yes. I don't know what's going on. I might not be able to use a calculator today. I don't know. I thought I bought a full license for it. I'll look in a second. It doesn't matter. Where am I going? Oh, we're back. Okay, let's get started. All right. So you know these reference triangles. These you should probably have available. We're going to have two. If this is my 30-degree angle, then opposite this would be a 1, and opposite this would be the square root of 3. If I label this opposite, adjacent, and hypotenuse, I don't have really good colors. Remember, we're going to label this one for the 30, so clearly this is my hypotenuse, opposite, and adjacent. Man, my penmanship has gotten so good. It's kind of hard to write on this, and I haven't done it in a while, so forgive me. This one we're going to do is a 60-degree angle, so anything that I come back and I want to refer back to a 60-degree triangle, this will be the 1. So hypotenuse is 2, opposite the 60 is the square root of 3, and 1. And you're probably saying to yourself, well, why'd you do that? Well, remember, if I label this one for a 60, that means this is opposite, this is adjacent, and this is still hypotenuse. Don't forget that, some old hippie caught another hippie tripping on alligators, or whatever you decide. SOHCAHTOA is also good. All right, let's talk about the 45, 45, 90. That's the easy one. That's the easy one. We got the hypotenuse of 2, and these are both the square root of 2 and the square root of 2. And remember, we got a 45-degree angle here, and you can label it any doggone way you want. Hypotenuse, opposite, and adjacent. Now let's talk about the unit circle. Some of you are going to like the unit circle, don't like the unit circle. It doesn't matter to me. We got 0 degrees. We got 90 degrees. We got 180 degrees. We got 270 degrees. We got 0 pi. We got pi over 2. We got pi. We got 3 pi over 2. And if we go all the way around, I got 2 pi. Enlightening. All right, so the other thing we talked about is the fact, what are the coordinates of these points? This point is 1, 0. This point up here is 0, 1. This point over here is -1, 0. And this point down here is 0, -1. Now, if you remember correctly, that when I'm talking about the unit circle, and this is only true of the unit circle, the x value is the cosine of theta, and the y value is the sine of theta. Tangent theta will be y over x, because we all know that tangent of theta is sine over cosine. All right, that's all the preliminary work. That's all that work. So let me get started on this. I'm going to pause for a second, and I'll be right back. I'm back. Time for some coffee. And I just went over to my shelf and bought my Dunkin' Donuts coffee cups. So there's Dunkin' Donuts in here. All right, let's get started on this baby. We're going to grab this trig function right here, wherever the heck it is. Can't find it. All right, so move it on. I'm going to slide it over a little bit too. Is there a way to slide this thing over? Okay, whatever. You know what? I'm going to do it over here. to go touch my monitor. I'm working on a laptop. All right, so let's get through this. We know that our amplitude A is 3. We know that our B value is 2. And we know that our period, which is defined as 2 pi over B, is equal to 2 pi over 2, which is just pi. In other words, I will finish one full curve in pi. I'm going to use as my x scale. Remember, we just take period and divide by 4. So I'm going to take pi over 4. My C value for this, I believe, was 1, positive 1. My max will be C plus A, which is 4. And my min will be C. I don't know why I was going to write max again. I don't even know if you can see that stuff there. And my penmanship has just gotten even better. Let me try to slow down. C minus A, which is 1 minus 3, which is negative 2. All right, so let's get back to our graph. You remember correctly, we always start graphing from the midline. But I need to put some stuff on here. So this is pi over 2, or pi over 4. This is 2 pi over 4, or pi over 2. 3 pi over 4 and pi. Notice I ended at pi. And because I said from negative pi to 2 pi, or from negative pi to pi, I'm going to have to go in this direction as well. I'll need 4 tick marks there, but I'll do that after I do the first curve. Okay. I'm going to sketch in my midline. Then, oh wait, I don't have a scale here. I need a scale here. 1. Good enough. 2. Good enough. So I need a midline, so let me do that in red. Oh, that's really annoying. Somebody's at my front door. All right, it's probably my dog having fun outside. He loves when I'm home. Okay, so what we're going to do is we're going to graph this thing. We're ready to graph it. Now, you have to remember when we graph sine, we're going to say to ourselves, we start at a 0 on the midline. We end on a 0 on the midline, and there's a 0 in the middle. Now I have to go to a max and a min. Because this is positive, we're going to go up first. Now you start counting at the midline. So we're going to start counting right here. And we're going to go 1, 2, 3. So my maximum is right there. And it's at 4. And I said if you come over here to look at the max, my max is going to be 4. I can't see that because it's behind my big bald head. There it is. So, and then I'm going to go to my min, which is negative 2. And I'll do a little quick sketch. Remember, we want some curves. Nobody likes flat sine curves. There we go. Now we have to do it backwards as well. So we're going to start at a 0, we're going to end at a 0, and we're going to have 0 in the middle. But now we're going to do everything in reverse. So down here and then up here. Don't do anything crazy so your graph looks all funky Cole Medina. Yeah, your parents would probably understand what that is if you got any parents around 50. All right, there we go. First curve done. I think that's so exciting. Let's get to the second curve. All right, so let me do my A, B, and C above this thing. So maybe that'll be easier. A equals 2. It's not negative. The negative just means we're going to do something a little funky at the beginning. B is 1. Period is 2 pi over B, so it's 2 pi over 1, which is just 2 pi. X scale is going to be the period divided by 4. You'll see why in a minute. So this is pi over 2. C is negative 2. My max is C plus A, which is goose egg. And my min, I got to slow down. C minus A is negative 4. All right. Let's get our scale on here. God bless it, that's hard to move. All right, scale. All right, good enough. Go away. 1, 2, 3, 4. Pi over 2. Pi. Sorry, I had to take a 2-second break. What are we going to pi here? 3 pi over 2. And 2 pi. And then we're going to go scale on the y-axis. 1, 2. I don't want to go up there because we're going to go down here. -1. Okay, we're going to start at the midline. The midline is -2. So we're going to do a little dash line there. Got to go to a different color. Let's go blue. -2. Bam. Remember, since this is just an imaginary boundary line, it's really not part of the graph. It has to be a dashed line. Otherwise, you're not doing it correctly. Okay, so I feel like I want to shrink this. Oh, there we go. That's better. That'll be better. Hopefully that's viewable for you guys as well. So this is the key. Normally what we would do is start at a max, end at a max, min in the middle. But because this is a negative, we're going to start at a min, which is down at -4. We are going to end at a min. And in the middle, we're going to be at a max. Remember, our max is 0 and our min is -4. In between those, we got zeros. So don't forget to put some curves on it. Everybody loves curves, cosine curves. Okay, that's the cosine curve. We're going to start at 0, end at 0, max in the middle. Remember, we should still have 4 tick marks here, right, for our 4 points. And in between these, we will go to zeros. And we'll go, what is that? Okay. So long as you make a viable attempt to make some curves, we're okay. Sorry to the 2 kids in class. You guys in 3rd period know the joke. It's sort of not a joke. It was just a fumbling verbal faux pas. Screw up. All right. Have fun. I'll be right back. I'm almost out of coffee. I'm how we're going to make it through this. Now, I know there's at least 1 or 2 or 5 of you saying to yourself, my God, Mr. Krause, your hair is luscious and long and gorgeous. And what's with that beard? And now you can look to see how gray I am and how old I am. Yeah, it's my Corona dew. Okay, I'm making jokes. I really just glad you guys are home. I hope you're healthy. I hope you're safe. Stay away from other people. Wash your hands. Yeah, all the other stuff. But I'm glad you're healthy. I can't wait to get back to school. But until then, this beard's growing. Drive my wife crazy though. She hates it. Doesn't matter. Anyway, let's get going to tan. Now, when we graph tan's pretty simple, but you have to remember they have issues. Yeah, kind of like, some of my kids. I haven't made a video from 2020 yet. I don't think I have I? So I should probably start calling out some people that are pains in the neck. Maybe I should just use initials. That's too light. Let's talk about domain of the tangent curve. So remember, domain. I'll write this as if it's normal. So x isn't a set of all reals, but remember, what we have with tangent is it cannot equal plus n minus pi over 2 and plus n minus 3 pi over 2. Now, okay, really it can't equal plus and minus n pi over 2 where n is an odd integer, but we're only going to graph it from -2 pi to 2 pi. So I still need a scale. So I still need a scale. And if I remember correctly, and I do because I'm kind of smart, this is going to be pi over 2, pi, 3 pi over 2, and 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Now, I only need those ones so that I make sure I get the right asymptotes. All right, let me get my asymptotes. I'm going to do my asymptotes in a slightly larger. Why can't I? Oh, this is the other end. Now, whatever. We'll leave it like this. Asymptotes. Asymptotes at negative 3 pi over 2. Nice dotted line. Dash line. Negative pi over 2. Pi over 2. And 3 pi over 2. Now, in between those, you'll recall we have zeros. Man, is that? I need a thicker pen. Yeah, there we go. So we'll go here, 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 and here. And if you remember, cotangent curves up. Go close to the asymptotes, but do not cross them. This one, we're going to go on this side. Reach, reach, and reach. There we go. Tangent. Done. Oh, probably should talk about range just real quick. Range is just the all reals. Range is all reals. So range y is in the set of all reals. Good enough. That's range. All right, we're going to do cotangent curve. So let me get back to my black pen. Ring, 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 ring. Cotangent is actually a little bit easier to graph than tangent is, because the domain for cotangent is x is in the set of all reals, but x cannot equal plus and minus pi and plus and minus 2 pi. So pi over 2, pi, 3 pi over 2, 2 pi. Oh, I said plus and minus 2 pi, but this should also say x can't equal 0, right? Plus and minus 2 pi. All right, by saying plus and minus 2 pi, I'm actually saying also x can't equal 0. But I know some of you, that'll mess a little bit of you guys up. Negative pi, negative 3 pi over 2, negative 2 pi. So let me get my asymptotes in. Negative pi over 2. Negative pi, 0. I guess x equals negative 2 pi is not quite the same as x equals 0. So I should have put x equals 0 on there. All right, there's that. Now let me graph my tangent curve. Now in between the asymptotes, we're going to have zeros. Why is that? Maybe it's this one. No, that's a highlighter. All right, so this one, this one. Now what you got to remember about cotangent is it squiggles down. I'll do my very best. This pen is very difficult to write like that. Gosh, that's hard to go right. All right, so that's the cotangent curve. All right, there we go. All right, let's get on to some math problems. We've done graphing for a little while. All right, so this question says, if angle theta is drawn in standard position, and this is 5 pi over 4. So you know 5 pi over 4 means we have a reference angle of 45 degrees. So if I was to say, okay, we have a reference angle of 45 degrees. So if it's on the unit circle, oh, okay, this problem is wrong because it should say if x and y is on the unit. This should say this is a unit circle, unit equal circle. So we're really talking about a unit circle here. So, okay, if this is the unit circle, then I know that x equals the cosine of theta and y equals the sine of theta. So I don't really need this. What I need is my reference triangle. The idea that it's the unit circle tells us this information, that the x is the cosine of theta and the y is the sine of theta. So I'm going to go back to my reference triangle, and I'll say, okay, if my reference angle is 45 degrees, and I get that from here, then I know that the cosine of theta is the square root of 2 over 2, and the sine of theta is the square root of 2 over 2. But we are in quadrant 3. And because we are in quadrant 3, x is going to equal negative square root of 2 over 2. And so is y going to equal negative square root of 2 over 2. All right, let's do a little proof action. This one looks rough. This one looks rough. Okay. So let's see what we got here. So all I'm going to do is distribute this for now. Remember, can't touch this. Can't touch this. Can't touch this like my beard. Oh yeah. Leave comments down below what you think. And don't say how gray I am. Make me feel old. All right, so sine squared x plus cosine squared x minus cosine x tangent x equals 1 minus sine x. Holy crap, this is going to be easy. This cannot be this easy. All right. You should know by now, as soon as you see something like this, that that's 1. And this, we're going to have to do something with. So let's make this, ooh, that's really thick. Let's make this 1 minus, this is going to be cosine x over 1 times sine x over cosine x equals 1 minus sine x. Well, if this is true, then these cancel. And I'm left with just sine x. So now I'm done. 1 minus sine x equals 1 minus sine x. So from something that looked ridiculously difficult to something that within a couple of steps I got. So don't fret out, don't go crazy. It's not going to be that bad. Write an equation for the sine curve, blah, 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 blah. So first of all, get off my screen again. We have a sine curve. So I'm going to write the generic version of the sine curve, y equals a, I know it's bugging a few of you, sine bx plus c. Now let's go through this thing. We have an amplitude of 5, so a equals 5. It is reflected in the x-axis. This means we need a negative. So we already got half this done. -5 times sine. All right. And we shifted vertically up 3 units plus 3. So again, the only hard part about these problems is to figure out what the frequency is, the b value. That's all we're looking for right now. So that comes from this. If you remember correctly, period is equal to 2 pi over b. And what we're looking for right now is that value. All right, so we know that the period is 5 pi over 3. That's got to equal 2 pi over b. So cross multiply, I get b times 5 pi equals 6 pi. Divide by 5 pi, and I get b equals 6/5. And there is the answer to your questions. Shabam! Oh, this is a rough question. Rough. Let's, I don't know how that happened. Go away. I was just about to touch my non-touch screen again. All right, there's a lot going on with this question right here. So first things first, this is sine in the second quadrant, or in the third quadrant, that's negative. This is cotangent in the fourth quadrant, that's negative. And this is cosine in the second quadrant, so that's negative. So I have 3 negatives. I'm dealing with those negatives right now because I know I got issues. This one has a reference angle of 30, 30, and 30. Well, isn't that nice? All I need to do, come on, how was I that nice to you? All I got to do is worry about a 30-degree reference angle. So 30. Maybe I bet the test one's harder than this one then. All right, so opposite the 30 is a 1. Opposite the 60 is the square root of 3. This is 2. This is going to be my adjacent. This is my opposite because it's opposite of the 30. And the only thing I'm talking about are 30s. And this is my hypotenuse. So, some old hippie caught another hippie tripping on alligators. So, cosecant would be hypotenuse over opposite. So, we already said it's going to be negative 2 over opposite, which is 1. Okay. Cotangent is the opposite of this, so that'd be adjacent over opposite. We already know it's negative. Adjacent over opposite, that'd be the square root of 3 over 1, times secant, which is the reciprocal of cosine, so that'd be opposite over adjacent. We already know that's negative, and that would be 2 over the square root of 3. Wow, this problem turns out to be actually relatively simple. These cancel, and I end up with a negative times a negative times a negative is negative 4. Wow, that was crazy simple. Okay. Convert the following to degrees. I think these should have pi's on them. I don't know why they don't, but they should have pi's on them. So to convert to degrees, we just multiply by 180 over pi. Let me pause for a second. I'll be right back. Alrighty, we're back. Okay. I actually had to get my stupid machine working. My stupid machine is up and running. So we're going to get rid of these pi's. And we literally just type that in our calculator. We come over to the old calculator, say, hey, dumb machine, do control division, 11 over 4 times 180. Shabam! What do we got? 495 degrees. 495 degrees. And you knew if we divided by 4, we're going to have a 5 in there, right? Boom, 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 boom. Multiply by 11 pi over 6. Now, we're going to multiply by 180 over pi. Now, this is really close to 2 pi, right? 2 pi would be 12 pi over 6 with a reference angle of 30 degrees. So I know this is going to be 330 degrees right away because we're almost all the way around a circle with a reference angle of 30 degrees. So I know this is true, but let's just verify it is true. Control division, 11 over 6 times 180, 330. There we go. Bam. All right, to convert to degrees to radians. Okay. Now, just for fun, though, if I didn't want to use my calculator, I could do this. I know I'm in this quadrant, and I know I have a 60-degree reference angle. Well, 60-degree reference angles means we're going to divide by 3. This would be 3 pi over 3, so that means 240 degrees must be 4 pi over 3. Now, the way to do it is just grab your calculator and multiply by pi over 180. It is the reciprocal of this, right? And in your calculator, the only thing you need to do is control division, 240 over 180. And you get 4/3, so the answer would be 4/3 pi. Now, 480 degrees, holy crap, that's that's 120 degrees past 360. So that means we have another 60-degree reference angle, but this time we're in the second quadrant because it's 120 degrees would put us in the second quadrant. You know what I'm talking about like this? If I start here and I go, well, there's 360, there's 480, there's 480 degrees, so we have a reference angle of 60. So I know the answer is 2 pi over 3, but it really doesn't matter. Actually not 2 pi over 3, excuse me. This would be 6 pi over 3, would be 360 degrees, plus another 2 pi. So I know my answer is 8 pi over 3. But again, you don't need to worry about that because you just grab the old dumb machine. You say, hey, dumb machine, help me out. Some of you are better at the dumb machine than others, which means you just use it too much. 8 pi over 3. There it is. 8 pi over 3. Bam. Equals. What is the exact value of cosecant of 300? So, 30, 60, 90. 300 degrees is a reference angle of 60 degrees. So we're going to use this one to mark this. Remember, opposite the 30 is 1. Opposite the 60 would be the square root of 3 every single time. So let's see. This is this reciprocal of sine. So this is hypotenuse over opposite. So the cosecant of 300 degrees is equal to hypotenuse, which is 2. Oops, we're labeling this for 60, right? 60 degrees. So this would be opposite, this would be adjacent, and this would be hypotenuse. So 2 over the square root of 3, but we're in the 4th quadrant because 300 degrees is in the 4th quadrant, so my answer is negative. Can't leave it like this. I got to multiply by the square root of 3 over the square root of 3, so I get negative 2 square root of 3 over 3. Bam! What is the exact value of the cotangent of 240? So again, 240 also has a reference angle of 60. Opposite here would be 1, 2. This would be the square root of 3. Let me label it. This would be the hypotenuse. Remember, we're doing a 60-degree reference angle. This would be opposite, and this would be adjacent. Now, tangent is tripping on alligators, so cotangent is alligators on. So adjacent over opposite. So the cotangent, I just wrote cosine. The cotangent, let's try, jeez, of negative 240 degrees is equal to A over O, 1 over the square root of 3. Now, some of you might think, oh, 240 degrees, we're in the third quadrant. We are not in the third quadrant. Why are we not in the third quadrant? Because negative 240 degrees is this way. So this is theta. This puts us in quadrant 2. And cotangent is negative in quadrant 2. Multiply by radical 3 over radical 3. And I get negative radical 3 over 3. Shabam! Done. All right, so this is a sine curve. Now, if you didn't know this is a sine curve, you could put the midline in. Now I'm going to do a midline in a dark line just so I can see it really well. Start at 0, end at 0, 0 in the middle. That's clearly a sine curve. How am I going to find all these values? All right, let's go find the amplitude. The amplitude is up 2, up 2. So y equals 2 sine plus. Oops, this is not going to be plus because we're going down, right? Aren't we going down 3 to the midline? So minus 3. So again, the only tricky part is B. Remember, B is frequency, the number of full curves in 2 pi. Well, let me go take a look at this thing. Maybe. I'm going to highlight one full curve. I'm going to do it in a big green pen. Hopefully a big green pen. I'm going to highlight one full curve. All right, that's one full sine curve. It finished in pi. So the period is equal to pi. That means it's going to finish 2 curves in 2 pi. So when I go back to my equation, I know I'm going to finish, my frequency is 2 full curves. Now, the only thing that I got to find out and I got to think about is whether or not I need a negative or not. And oh, come on, slow down there, sister. Remember correctly, normally with the cosine or the sine curve, we go up first. But in this case, we went down first. So I need a negative. All right. Let me pause it up and be right back. All right, kids, here we go. This looks like it's going to be a cosine curve. Let me find the midline. Now notice this is the top. This is the bottom. So my midline is going to be right about here. Well, that's weird. We're at negative 3 again. So my midline is negative 3. So C equals negative 3. Where it looks like our amplitude is 2 again. So we got y equals 2 cosine minus 3. So we got to do 2 things. We got to decide whether or not we need a negative. And then we got to decide what our frequency is. So I'm going to go over here and blow this up one more time. Now, here's what I'm going to look at. Now, this is going to be a little bit tricky. I want to finish this cosine curve. I want to finish this cosine curve. So let me go back to my, this isn't going to be thick, is it? Shut up. All right, I'm going to do one full curve. So there's one. And back here, right? That's one full curve. Well, it finished half the curve in pi. This is pi, by the way. So that means it would finish the curve in 2 pi. One full curve, one full cosine curve in 2 pi. Well, then, okay, that makes it a little bit easier because that makes my frequency just 1. Now, I don't need to put a 1 there, but you could. Now, I got to decide whether or not I need a negative. And again, I know it looks like it starts at a max, ends at a max, but remember, we use the y-axis as our starting point. So it is starting at a min, and if I finished it, it would end at a min. And that means we need a negative out front. So there's the answer to that question, kiddos. All right. Is this the last problem? Oh, we got a lot more. Jeez. All right, so this would be a big question. Let me deal with this one. Nah, let's not do that. Let's do this. We got to figure out what quadrant we're in. So sine is negative. That means I'm down here or I'm down here. Cotangent is positive. That means I'm either here or here. So now I know that we are dealing with this triangle right here. That's the one we're going to deal with. And what did it tell us? God bless it, that's hard to move. It told us that sine is -7 over 25. All right, let's go back to that. So sine is -7. Sine is opposite over hypotenuse. So -7 over 25. Now, I'm not going to do the Pythagorean theorem for you. You can do it, but this would be 24. Okay. So now I'm done. The easy part's done. Sine of theta, -7 over 25. Cosecant theta, -25 over 7. The cosine of theta, 24 over 25. Now, if I remember correctly, that's going in this direction, so that's negative. That's -25. And the secant of theta is -25 over 24. Tangent of theta equals opposite over adjacent, so that'd be -7 over -24. So that's just +7 over 24. And then cotangent would just be the flip of that. Why do I keep writing cosine? Cotangent of theta equals 24 over 7. Notice these are the only two that are positive because we are in the second quadrant, or excuse me, the third quadrant, and only positive in the third quadrant is tangent and cotangent. Here's another way I can ask the same question. I'm going to figure out which triangle I'm dealing with. So we're going to go -5 and +12. That puts us here. And again, I'm not doing the Pythagorean theorem, but you can do it to find out that that hypotenuse is 13. And so now I can just write all these out. Sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent. Oh, I did it. I actually had to think about it. All right. Some old hag caught another hag tripping on alligators. Man, I wish I could do like one taking toilet paper away. So sad. Sorry. It is so sad to watch old people and even young people. I mean, if there's young people fighting over toilet paper, oh my God, what the heck? Oh gosh, whatever. So sad. Sine is going to be opposite. Remember, we're talking about this angle, right? So this is opposite, this is hypotenuse, and this is adjacent. And anytime you do the bow tie, this is always going to be the opposite. So 12 over 13, 13 over 12. We're in the second quadrant. Cosine is -5 over 13, -13 over 5. And then this is just going to be -12 over 5 and -5 over 12. Boom, done. When you get to problems like this, simply do this. Cotangent, that's really tangent, is negative. Cotangent is negative here and here. Sine is positive here and here. Remember, because it's all students take calculus. So the big winner is quadrant 3. We'll do it one more time for you. All students take crap from their math teacher. Let's see, cosine is positive. Cosine is positive here and here. Tangent is positive. Tangent is positive here and here. Oh my gosh, the big winner is quadrant 1. That was boring. So this should look very, 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 very familiar to you. Sine squared plus cosine squared equals 1. Well, if that's true, that means these two things, whatever they are, this is alpha, this one's beta. Alpha has to equal beta. So if alpha was 55.2, beta would be 55.2. They just have to equal each other. That's it. We're almost done. Let's see here. We have a negative. We don't have a negative. So that's a reflection in the x-axis. Got a 2, got a 2. No dilation. We have this. Now remember, anytime you add or subtract inside the movement, that's a translation left or right. So we are going to have a translation right 2 pi over 3. It's right because remember, if it's in the parentheses, it's opposite. And down 4. This one's down 4. Simple as that. All right, let's go through these. Let's do the sine and cosine first. This one's either sine or cosine, and this one's either sine or cosine. Notice we always look at the y-axis. Sorry, you can't see these. But since this one's starting at a min, ending at a min, this one's cosine x. This one's sine x. Squiggles up are tangent. Squiggles down are cotangent. All right, now if I connect these dots, start at 0, end at 0, oops, end at 0, and 0 in the middle. It should be 0 in the middle. This would be, the green curve would be sine, so that means this is cosecant. If I connect these points, start at a max, end at a max, this is secant. If I squiggle weird one, this is the weird one, and I go through the origin, so I got the weird curve and it goes to the origin. This is sine inverse. And if I squiggle weird and got the weird curve that just stops there, but I don't go through the origin's down here, this is cosine inverse. And the only one that's not on here, and it looks like if somehow it's missing, I don't know why, should be tangent inverse. Tangent inverse is the same as tangent, but it squiggles left and right. It almost looks like a cube root function, sort of. All right, kids, you know how to do that. You know how to do the test. That's it. Good luck. I don't know what to expect after this. Maybe a full beard? Maybe not. Anyway, good luck, kids. Work hard. Do not cheat, but you can help each other. You can look through your notes. This should be a relatively easy test with your notes and all of the stuff that we've done here. This should be a relatively easy test. Get this to me as quickly as possible so I can grade it. After that, I don't know what we're doing. All right, kids, goodbye. You know, as always, have fun storming the castle. A little elbow bump, a little foot stop.